Hello friends, welcome to the third tutorial of three-phase circuit analysis. In this tutorial we'll talk about relationship between line and phase voltages and currents in delta connection. A delta connection looks something like this. It has three windings which are connected at three different nodes, resulting in three different lines with three line currents. Now just by inspecting this network we see that uh, this line current IR has been derived from uh, the division of these two currents, which are of course the phase currents. The reason they are phase currents are because this current is flowing between the points of phases blue and red, which is denoted by IBR, and this current is the current flowing between the phases red and yellow. So if I label this point as R and this point as B and this point as Y, the currents flowing in these branches will be the phase currents. So the phase currents are going to be IBR, IYB and IRY. And the line currents are going to be IR, IY and IB. Please understand, the line currents are the currents which are flowing on the actual transmission line, because the currents will be carried on these lines which will go far off to some load, and that load could be a star or a delta connection. We'll solve those numericals and we'll actually find out why line currents are so very important. Now, but here if you observe that the line current IR is derived from these two currents, and similarly the line current IY is derived from IRY and IYB, and there is of course a relation between the currents at a particular node. So applying the Kirchhoff's current law, we get these three relations. We know that IR is equivalent to IBR, the current entering, and IRY, the current leaving, and so on and so forth. So as far as calculating this expression is concerned, over there we'll need to have some knowledge of the vector diagram of the line currents. We know that in three-phase circuits, these phase currents, they are going to be separated from each other by a phase of 120 degrees. So drawing the very basic nature of the phase currents in a delta connection, we know that the three phase currents are going to be separated from each other by an angle of 120 degrees. So if I was to calculate IR, which is IBR minus IRY, so I need to extend this to the negative territory and I get minus IBR, and then I can simply find the resultant using the diagonal method of vectors. So this becomes my resultant vector IR, because this is what is depicted here. So I can safely say that IR is equivalent to IBR square plus IRY square plus 2IBR IRY cos of 60 degrees, because this angle is going to be 60 degrees. and I assume that IBR is equivalent to IYB is equivalent to IRY is equivalent to phase current. So IR is twice of phase current square, twice of phase current square into cos of 60 degrees, or in other words it comes out to be equivalent to under root 3 IPH. So, and IR is nothing but the line current. IR will come out to be equivalent to under root of 3 IPH, and this is a super important relation or the equation for the delta connections. So we know that the relation between the phase voltage and line voltage in star connection was of this nature, but the relation of phase current and line current in delta connection is of this relation, where the line current IL is equivalent to root 3 times under root 3 IPH. And if you look closely, the voltage between two lines R and Y is nothing but the voltage between these 2 points. So the phase voltages and the line voltages, they will remain the same. There is no difference between the phase and line voltages. You can look by inspection that the voltage between R and Y is going to be the same voltage which is there between this winding. So VRY is equivalent to VYB is equivalent to VBR is equivalent to VL, or the line voltage, or is equivalent to the phase voltage. In star connection, the line current was equivalent to the phase current. In delta connection, the line voltage is equivalent to the phase voltage. So these are the 2 points that you need to keep in mind. So I highly recommend that you watch my previous video where I discussed the star connection to make a comparison of the 2 connections, and then you could appreciate the fact that these 2 relationships are so very important, and they are exactly opposite in nature in star and delta connections. And once you know these basic formulae, then you will be able to solve any multiple choice question or university examination. And I hope this quick fire tutorial was of help, and if you liked the video, give it a thumbs up. I'll see you in the next video. Take care. Bye bye.